we're going to go over the EPA, and we're going to break it down into several different classes so I can explain different parts to you. The exam itself, if you see here, is made up of 4 parts. The first part is core. Core is 25 questions, and it's all about the chemical makeup of Freon, the laws, and how to handle the Freon and everything else. Type 1, Type 2, and Type 3 are based on the type of appliance. A Type 1 appliance is what we normally do as in refrigerators, small wall window air conditioners, and we'll go over the definition of that when we get to that section. Type 2 is more like central air conditioning, and they say MVAC, which is motor vehicle air conditioning, and so forth. And then Type 3 is for low pressure. These are chillers. These are big units. We have some chillers in our school, and we have chillers in like big, tall buildings, and we'll break down what a chiller is and how a chiller works in that section. And those 3 sections is how do you handle servicing, charging, recovering, all about refrigerant with that product. It's not about how to troubleshoot and repair a chiller. It's what do I do regulation-wise or law-wise when I'm working on that product. Now, each one of these sections contain 25 questions. If you pass Type 1, Type 2, and Type 3 and do not pass core, you will not get a certificate. You must have core in one of the types to get any type of certification. You only need core in Type 1 in our industry, but I recommend that you study and take the whole test. If you don't pass the other 2, that's fine. But if you do pass it, you'll have a certification called universal certification. And in the future, it might allow you to work on other things besides just regular small appliances. So each section has 25 questions, and each one is graded individually. So you must get 70% on core, 70% or better on Type 1, 70% or better on Type 2, or 70% or better on Type 3 to pass that section. Okay? So technically, 70% is almost like 6 or 7 questions out of 25, and you can still pass it. So if we practice it and you study it, and you do the practice questions that I provided you on Kia, you should be ready to take the exam when you're hitting those questions on Kia close to 100%. Now, I still haven't had a chance to update those questions because there are some new things that have come out in the past year. So we'll talk about them as we go through. So let's talk about what are we doing this for? Why are we studying for an EPA license? Well, the bottom line is, if you look here, I have a sample of what we call the different layers around the atmosphere around the Earth. Starting down here is the troposphere. The troposphere is about 10, 11 miles, about 6 to 7 miles above the Earth from the ground up. The stratosphere is from the top of that one, which is about 6 or 7 miles, to about 30 miles. And then from 30 miles to about 52, 53 miles, we have the mesosphere, and then we have the thermosphere above that. What do you need to know? You need to know stratosphere. The stratosphere is the most important part of this because it is what holds our ozone layer here. You see I'll move it down a little bit. It's what holds our ozone layer. The ozone layer is nothing more than 3 oxygen atoms. If you look here, we got 1, 2, 3. And ozone is a protector of ultraviolet radiation from the sun. So what do we breathe? What is it you breathe in?
Oxygen.
Yeah, but oxygen is made
Nitrogen.
of what? What?
Oh, I was just saying we have nitrogen in the air, oxygen, carbon, right?
No, we just
Hydrogen.
breathe in oxygen, but what type of oxygen? we breathe in O2, which is only 2 parts of oxygen. Can we
Yeah.
breathe? Can we breathe ozone? Yeah, but it's harder for us to breathe because it's thicker.
Is it going to be thinner?
It's almost like a milkshake. You know, it's too thick. So ozone, as thick as it is, stands about 7 to 10 miles above the Earth, and you can see where this little light stripe is right here. This area is where the ozone layer is. So as the sun's rays are penetrating into the Earth, then these ultraviolet rays here are trying to get into our atmosphere. But when they hit the ozone layer, they are reflected out and away from the Earth. So it protects us. And what are we concerned about? Well, the ozone layer protects us from the ultraviolet lights. Ultraviolet lights can cause all kinds of problems. They can cause skin cancer. They can cause cataracts, and I don't know. I think it's spelled as that way, cataracts. It can reduce crops, and it can reduce marine life. So in other words, too much ultraviolet radiation is no good. I just installed one of those UV lights in the air conditioner in the office because of this COVID virus, and I was trying to kill the germs in the AC by using an ultraviolet light. That is how they do it on air conditioning units. And I got a little UV handheld wand. It looks like a lightsaber from Star Wars. And you hold that over the keyboard for like 10-15 seconds, and it kills all germs. So that's a good thing about the UV. But the skin cancer here is probably one of the worst things that could happen. That, you know, you go out in the sun, and you know if you get too much sun, they say, oh, you're going to get sunburn, be careful, you can get skin cancer and everything else. So if you pay attention to the news, sometimes in the summertime they'll tell you, oh, the UV rating is this or the UV rating is that. That's based on how thick is the ozone layer. So what is happening? Ozone has 3 parts of oxygen like you see here, and Freon contains chlorine in some of the Freon that we have, R12, R22, R11, R500. All these refrigerants are made up of different types of chemicals, but they all they all contain some sort of chlorine atom inside of it. So when the Freon is let out of a refrigerator or out of an air conditioner, they say the wind picks it up and drags it up into the stratospheric ozone, and the chlorine atom that's mixed with that refrigerant breaks away and attacks the ozone molecule, the O3, like you see here. And then when the chlorine atom attacks it, it robs one of the oxygen atoms, making something called chlorine monoxide. And then leaves 2 more oxygen atoms. They call it diatomic oxygen. It's basically oxygen O2. So now we've lessened or reduced that filter that it does for the UV rays by breaking the ozone layer down. Now they're saying that this chlorine atom can destroy up to 100,000 ozone molecules. Okay, so this chlorine atom meets here. This oxygen meets another oxygen, becomes an O2. Then the chlorine itself comes right back around and breaks up another ozone layer and steals another oxygen atom out of there. And this can happen up to 100,000 times. So if I'm writing this down, this is the stuff you need to know for the test. You need to know it's chlorine that messes up the ozone. The ozone's made up of 3 oxygen atoms, and that the chlorine monoxide is the chemical that is found when it has 1 chlorine atom mixed with 1 oxygen atom. So chlorine monoxide, mono meaning 1 oxygen, and then it breaks it down. So, and you need to know 100,000 ozone molecules can be destroyed by one chlorine atom. And that sounds like a lot. And when we say 100,000, if I gave you $100,000, that'd be a lot of money, right? But 100,000 atoms, you cannot physically see an atom with your eyesight. You have to see it with a microscope. So 100,000 atoms, I don't know how much that is, but I would gather to say it's about the size of a ballpoint pen. It's not really as big as you think it is. But if you get enough chlorine out of there and then you multiply it, instead of being 100,000, it's millions and millions. Now, what makes ozone is usually lightning. An electrical charge, if you were ever close to like a lightning strike, you'd smell like a little bit of a pungent smell. And what that is the electrical charge in the air will fuse oxygen atoms together to make an ozone molecule. But ozone at Earth level does not protect us. We need that ozone in the stratospheric level. So it's not that easy to replenish, but we're not talking about the entire world has a hole in it, but there are spots up there in the ozone layer that are thinner than others, and ultraviolet radiation can get in. So let's take a look at a couple of the questions here in the exam here. And the first question, it says, which of the following gases help form the Earth's protective shield? So what's the answer there?
That's the same.
It's stratospheric ozone. Okay? Now, ozone depletion in the stratosphere is what type of problem?
Global.
It's a global problem. Okay? Now, let's talk about ozone depletion potential. I have that in my presentation. Refrigerants ozone depletion potential. We have CFCs, HCFCs, and HFCs. And in our old paperwork, that was the only three refrigerants that we talked about. But now we've added HFOs. That's at 600A. Now, CFCs are chlorofluorocarbons. And those are refrigerants that are, for example, R11 and R12. We don't use them anymore. They've been phased out and they've been replaced. Do you know what they were replaced to?
Isn't the butane?
Well, what refrigeration, what freon do we use in a refrigerator?
134A.
R134A. So
Yeah.
the R12 was replaced with 134A. Okay? Now we have HCFCs, and those are like R22, R502, and some of these other refrigerants.
What
Now,
about R600? Isn't that new?
that is part of the HFOs,
Okay.
and I haven't got to that yet. Before I get to the HFO, I want to talk about the ozone depletion potential on this screen. The higher amount of chlorine that a refrigerant has, the more ODP, and you're going to see ODP here, and that's short for ozone depletion potential. So the higher ODP is the more chlorine that's found in that refrigerant. So CFC stands for chlorofluorocarbon. HCFC stands for hydrogen chlorofluorocarbon. HFC says hydrogen fluorocarbon. And then HFO is hydrogen, fluorine, and oxygen. I think it's oxygen. I think that's what the O is. Now, if you see the first two have chlorine, 134A doesn't have chlorine. So when we were looking at, okay, well, what refrigerants harm the ozone? Well, believe it or not, R11 and R12 were rated as a 1.0, which is like the highest rating you can get. The rest are like decimal points. So they said, we got to start phasing these out. So over a period of time, they got rid of those refrigerants or replaced them with other refrigerants. Then they started removing R22, which is now R410A, which is also an HFC. which they have very little or very low ozone depletion potential. But the problem with those refrigerants was they didn't harm the ozone, but they had what they call GWP. I think it's GWP, but I'll just put GW, global warming. Now, global warming is not the same thing as ozone depletion. Ozone depletion harms the ozone layer and allows ultraviolet light in. Global warming is something called the greenhouse effect. So that means the sun heats up the earth, and that heat's supposed to escape back into outer space. But if we have refrigerants trapped in layers of atmosphere above us, it keeps that heat in, almost like putting aluminum foil around warm food to keep it warm. And so what happens is the sunlight heats up the earth, and then the earth gets warmer. And so you hear a lot about presidents and everybody say, oh, we got to worry about global warming, global warming, global warming. So we don't want to let 134A out into the atmosphere. A lot of people say, well, if it doesn't have chlorine, it's not going to harm the ozone. Why worry about recovering that refrigerant? But it affects global warming. So HFOs were invented, and that was R600A. Now, these refrigerants have been around in Europe for almost 20 years now. The thing is they contain isobutane, or they contain butane in them, which is what's inside your lighter. And that's very flammable. So its flammability was not that high, but its global warming was a lot lower than R11, R12, R22, R134A. And that's one of the reasons now we're changing from 134A to 600A. Now let's take a look at this chart over here. This chart talks about flammability, and down here you got what they call toxicity. All of these refrigerants, HFCs, CFCs, and CFCs, are what they call an A1 classification, except for R123. That is a B1 classified refrigerant. So I'm going to go ahead and put that up here, because that will probably be a test question. R123 is a B1 classification. Means it's a little bit toxic. It's not going to kill you if inhaled, but it can cause serious problems with your respiratory. In A1 refrigerants, if I let Freon into the air, and I don't totally replace the oxygen with Freon so you pass out, if you inhale refrigerant that's a A1 classification, it's not going to harm you. It's odorless, it's colorless, and it's not toxic to you. So if you see here in the column on the left, A1 is the most safest refrigerant, but as we go up in numbers, that we've added what we call flammability, where A2L is slightly flammable, A2 is low flammable, and A3 is high flammable. R600A is an A2L. I haven't seen the new test myself, but you might want to jot this down, that R600A is an A2L. So it's slightly flammable. If you let it out, it'll burn, but it's not supposed to be really high explosive or anything else like that. So most refrigerants are A1 except for 123, and 600A is an A2L. You need to know those two numbers for the EPA test. So going through here, let me just see, drop-in refrigerants. Let me talk about that next. When you're working on a system, and that system has R12 in it, and I said that 134A is now being used instead of R12. So 1970s, 1980s, 1990s, we made refrigerators with R12 gas inside of them. And then the government said, hey, no more R12. So manufacturers had to redesign their refrigerators to use 134A. So they stopped making R12. Well, R12 and R134A use different types of oils, and those oils can't be mixed. So if you were working on an R12 system and it had a Freon leak and you took a torch and soldered up the hole or whatever and fixed that leak, and you don't have R12 now, you technically can't just put 134A in. Or if you're low on Freon, you couldn't add a little bit of 134A. If you do that, what happens is you end up mixing the refrigerants, and you're making something called a blended refrigerant. So going to drop-in refrigerants, when retrofitting or converting a system to use a different refrigerant, only EPA-approved substitutes can be used. Remember, EPA does not approve any substitute refrigerants as direct drop-in replacements to service an R22 or other system. So let me just do a search here for something, and R134A so I'm searching for an R134 blend equivalent. Okay, so R134 is a refrigerant, but you might find some of these other gases that are very similar in pressure and can be used similar to 134A. New blends, if we look here, an R134 alternative is virtually non-flammable. So 134A, the new blends R451A, 441B compromise with YF and with around 10% 134A. So in other words, these refrigerants are blended from a manufacturer. You cannot have a system 134A and add one of these other gases inside of it to get the system back up to proper pressures. If you are going to change the gas, you got to change the dryer filter. You got to make sure that the oil inside the compressor is compatible with 134A, and you would know that by the oil used in the gas that was in there before. And you must retrofit that. If you're going to 134A and that compressor had the wrong type of oil inside of it, you'd have to either drain the oil or change the compressor to a system that would work with that oil. So let's go back to our presentation here. There is no drop-in refrigerant when it's coming to talk about Freons. So if we're looking here at, I'm going to close this one. If we're looking here at the quiz, which compounds have the highest ODP? CFCs, HFCs, or HCFCs? Anybody?
HFCs?
CFCs. They might add HFO as an option in here as well. Which refrigerant contains CFCs? I gave some examples. If you look at the presentation, I didn't write it down. I didn't write it down.
Oh, no. Is it R22?
500. Did you say 500, Gerald? That's correct.
Yes.
That's correct. R500 is a CFC. An example of a CFC refrigerant is, and it was on that list, what was an example?
R22.
No. Another guess.
Ooh.
R12?
R12. What about an example of an HCFC refrigerant?
I'm looking on the sticks. I didn't saw the side. I'm sorry. So it's R22.
Well, what's the question? HCFC is R22. Very good. Which refrigerant is a chlorine-free refrigerant? Just look at the name. The first C in the name was chlorine, and the second C was carbon. Which one of those don't have the chlorine in it just by the letters?
CFC?
No. HFC.
No.
Gerald, minimize. Turn off your microphone. You're getting noise in the back. Okay, so let's go back to the presentation. So you can see the types of questions they're going to ask you is which refrigerants are CFCs and HCFCs. A lot of the temperature pressure charts, and I think I emailed you guys one, right?
Yes.
Let me go to that temperature pressure chart if I can open it up. The temperature
Chris
pressure.
said he's not going to be able to make it, by the way.
Huh?
Chris said he wasn't going to be able to make it.
Okay, no problem. So look at this temperature pressure chart. Look, HCFC, HFC, HFO, CFC, HCFC, HCFC, you get the point. So HFOs don't have chlorine and HFCs don't have chlorine. You don't have to memorize the letters and the numbers because you are allowed to use a temperature pressure chart when you take the test. So if I give you a copy of this for the test, you have to say, oh, which one doesn't have chlorine in it? It would be 134A, 600A, 1234YF, and 1234ZE. All those don't have chlorine. So if they're one of your options in the test, if you learn how to read what these letters stand for, you don't have to memorize which one of the numbers are the refrigerants that have chlorine and don't have chlorine. Also, this 1233ZD is also what we call an HFO, which is a hydrofluorocarbon. So let's go back to here. Disposing of disposable cylinders. So when you buy Freon and it comes in a tank, that tank is a disposable tank. That tank cannot be used for recovering. Sometimes back in the day, guys used to take and use them for air tanks. They'd pump air into it, and if their bicycle tire got low on air, they'd use it to fill air. But they're very dangerous because the valves inside of them aren't designed for charging and letting the pressure on and off. So disposable cylinders are what they are. They're disposable. So when you get rid of it, you have to make sure that all the refrigerant has been recovered from the unit and the cylinders are rendered useless, and take them to the metal recycling place so that someone else can't use that tank because it is dangerous. All right? Yes? Okay. Before you dispose of any appliance containing CFC or HCFC refrigerant, you must do what? Read the choices.
Recover the refrigerant?
Yes, to recover. And you guys, every time you work on a refrigerator, if you got to do a sealed system job, you always have to recover the Freon from there. Okay? What do you think would happen if you violate the Clean Air Act? Like you intentionally let Freon out, you cut the lines while they're fully charged, you don't recover. Which one of these choices do you think is the correct answer?
All of the above.
All the above. Now here, an award up to one amount may be paid to a person. Now I was looking at it in the book. I think that number has changed. Violation of the Clean Air Act. Now, a technician can be fined $44,539 per day per violation. That used to be $25,000 a day per violation. And let me tell you, I remember reading in magazines, Sears technicians got busted, and one tech got busted for doing 3 sealed system jobs in one day. So that's $25,000 per violation. So if he had 3 violations in one day, that's $75,000. Now, if he did it a couple of times in a couple of days, that could be a lot of money. I tell you what, if one of the guys in my company did that, they wouldn't be working for me no more. Okay? But how do they catch you? How do they know whether or not you recovered the Freon? How you know, the guy just walks up on you in the customer's house while you're working on a fridge and says, aha, I got you. What happens?
Well, they have to check your tank. You got to be recovering it in a tank. You can't just be letting it loose.
Yes. No? It's not just the recovery tank. They can weigh the tank to see how many ounces or pounds are in there.
Yeah.
But you are required to have a recovery log. The recovery log, you put down the customer's work order, the customer's name, you put down how much Freon you recovered, And if you put Freon back into the system, did you use the recovered Freon or new Freon? So you could recover 4 ounces from the refrigerator, change the compressor, and reuse those 4 ounces back in the refrigerator. There's nothing wrong with that. That means your tank's empty, but your paperwork reflects it. So if you get pulled over, you got to have a recovery log stating that. Now what happens if you put an access valve? Let's say yesterday we were talking about those bullet valves or those external valves. What happens if we put a valve on a system and we hook up our recovery machine, and in the middle of doing it, it breaks and it leaks Freon all over the floor or out into the air while you're trying to recover?
Pinch a line. You can get your vice grips.
Okay,
And
well, actually,
seal the thing.
I'm going to tell you, if the line breaks, get away from it. Because if it's liquid refrigerant that's coming out, you can get frostbite, and it's very dangerous as a liquid form as it vaporizes into the air. If it breaks, or let's say you go to a customer's house and the refrigerator had a leak and had no Freon in it, you record it in the log. If the unit had a burnout, the compressor windings burned out, and they contaminated the Freon, you cannot recover that Freon with a recovery machine because it contains acids and it contains harmful particles that could damage the recovery equipment. So you can vent that as long as you record what happened. Got there and there was no Freon in the unit, compressor had a burnout, could not recover the contaminated refrigerant, access valve broke while recovering the refrigerant. Now you can't use that for every single job you do, but you can record it and just say, well, there was no Freon in this thing, but I put 4 ounces of new refrigerant. So when you buy Freon, a lot of these parts houses, they're supposed to send copies of the receipt for the Freon to the EPA so they know you bought it. You have to show them you have this EPA certification, or you're not supposed to be able to buy Freon without this license. Okay? So this is why you have to have this license. So going back to the question here, on the test, the question states, an award can be paid up to a person. I did not see that in the book. The book said how much the violation is, but it did not state what the reward is. I'm assuming the reward is probably still the same as it was before, which would put it at, what is it, $10,000 per violation. So if you saw a technician working on a product and he takes and hooks gauges up to an AC and he runs the other hose into a jug of water and you see it bubbling, he's probably letting Freon out. And water is not a good way to catch the refrigerant. So you call EPA and they're going to follow that guy, and the first thing they're going to ask him is, let me see your recovery log. And even if he had a log, they're going to weigh his tanks, and if his new refrigerant tank and his old tank match up to what his logs say, then he's okay. If it doesn't, he's going to pay a fine. And if he gets a fine, you could get up to $10,000 as a reward for turning them in. So now number 12, the answer has to change, because it used to be 25,000, but the answer now is, as we have here in the manual, is 44,000. Why 539? Why did you make it 500 or 600? I don't know, but they made the fine higher as of 2017 to almost $45,000 per violation. So they're really strict about you letting Freon out into the air and making sure you don't do that. Okay, so I keep going to the wrong screen. I'm going to put 25,000, but I'm going to change this test question to say $44,539. Okay, let's go to question number 13. Chlorofluorocarbons, or CFCs, and hydrofluorocarbons, HCFCs, have the following similarity. What do you think is similar between the two refrigerants?
They have the same ozone depletion potential.
No, they don't. The CFCs have a higher chlorine content than HCFCs, so they have a higher ozone depletion potential. But they both must be recovered before opening or disposing of an appliance. So before you service the appliance or throw it away, you're supposed to have that refrigerant recovered. If a residential customer takes and says, oh, my refrigerator broke, I'm going to go to Best Buy and buy a new one, and they go buy a new refrigerator, and they throw the old one in the back of their truck and go to the scrapyard, the scrapyard will tell them to put it on the side. They will not allow you to throw it in the dumpster. And then it's the scrapyard's responsibility to recover that refrigerant before that refrigerator's completely disposed of. Okay? I see a lot of typos here. The and which refrigerant must be recovered before opening or disposing of an appliance.
All of the above.
All the above. Okay, so let's get into the presentation again. Let's take a look at azeotropic refrigerant mixtures. They contain two or more refrigerants at a certain pressure. An azeotropic mixture evaporates and condenses at a constant temperature. It acts like a single component refrigerant over its entire range. Thus, azeotropic mixtures acts as a pure compound. What the heck are they saying there? Any idea? Okay, if you look at R450A is a near azeotropic refrigerant blend containing HVO refrigerant designed to replace 134A. So you cannot make your own blend, but I'll give you an example. If you mix R22 and R500 together, if we go back to that temperature pressure chart, if you look at R22, which is right, there is no R22, is there? Well, let's say R12 and R123. Let's say we mix those two together. R12 at 5 degrees is 11 psi, but R123 is 25 inches in a vacuum at that temperature. But if I mix them together, what do you think is going to happen? What do you think is going to happen to the pressure if I mix these two together?
It may increase in pressure.
Well, actually, it'll probably be somewhere in between 25 inches of vacuum. It's not going to go higher than 11, and it's not going to go lower than 25. So if we mix those two refrigerants together, we might get something in between, which makes it a new refrigerant. Now, we got two different types of blends. We have the azeotropic and what we call near azeotropic or non-azeotropic. Azeotropic is you blend them together like chocolate milk. If I take chocolate milk and I take a glass of milk and pour it in a cup and I add some chocolate syrup to it and I mix it, if I let it sit there for a couple of minutes, it's still chocolate milk, right? It's still pretty much now chocolatey. The chocolate and the milk now have merged together and they're not going to totally separate. So that's close to an azeotropic blend. Now, what a non-azeotropic or zeotropic blend is, imagine something like vinegar and oil. If you take vinegar and oil and you mix the two together, don't you have to shake it up before you pour it on your salad? Yes? No?
Yeah, you should.
So if you don't mix it up, it'll be too much vinegar or too much oil. So the problem with a blended refrigerant is if you have a leak inside the system, it might leak unevenly. And if it leaks unevenly, let me just do a little drawing here so I can give you an example here. So let's say this is a container, right? And I'm going to draw a line here. Well, it'd be better if I drew a different color. I'm going to draw a line cutting this container in half, okay? So this half here is oil, and, well, actually this half on the bottom is water, and this half on the top is oil, right? So if I put a little tiny hole in the side of the container here, which would run out faster, the water or the oil?
The water?
The water, because it's thinner than the oil. The oil's thicker. So if water would run out faster, then if I tried to mix it back up, it's not going to be the same mixture it originally was. It's going to have too much oil and not enough water. Blended refrigerants are the same thing. If you have a leak in a blended refrigerant, it's considered fractionation. And what happens is, as the freon's flowing through a refrigerant system, it may have too much of one gas than the other and have a high pressure. And then when that gas leaves and the other gas gets a lot of that gas there, it might be a lower pressure. So you're going to have a range of temperatures and pressures at one given point. And that's called temperature glide. So two words you need to know is fractionation and temperature glide. And the main thing between that is fractionation is when you have a refrigerant leak that's a blend that leaks, that you'll have more of one refrigerant than the other. In order to charge that thing to get it back up to the right pressures, you cannot just add that blend back in. You would think, oh, well, if it leaked out, the blend had a leak, I can just get that same refrigerant blend and connect it to the system and charge it back up. Well, the problem is if it was like oil and water, and I lost more water than oil, and then I took a pre-mixed blend that was already properly mixed, it's still, what's in there is still not an even blend. So we call that a fractionation. And in order to service it, you must recover that, get it all out of the system, and then charge from the get-go. Now, when you charge a blended refrigerant, let me just do a quick Google search here. A blended refrigerant, let's see if I can find something here. Blended refrigerants, a lot of them have arrows on the tank. Let me see if I can find one. If you guys see it, let me know. I'm looking at the different tanks. No, I don't see it. 404A. It's not there. But when you charge with a blended refrigerant, the problem we have with blended refrigerants, okay, this one here, let me see, is that an arrow at the top of there? Let me see if I can zoom into that image. No. Okay, so when you blend refrigerants, or you charge with blended refrigerants, look at this image right here. This image shows you that you must charge, well, this is not good. You must charge with the tank upside down. So if you see this tank here, you have liquid refrigerant in the bottom half, and you have vapor refrigerant at the top. And as the refrigerant starts to get used, the liquid level forms at the bottom. This is still freon here, but in vapor form. But if you look at the color, this has more blues than reds, or more reds than blues. And then if you see here, this has very little blues and more reds mixed in with the gas. So you cannot charge a blended refrigerant as a vapor. You must turn the tank upside down so you get the liquid portion, because the liquid is the proper mixture. And that's the only way to charge with liquid refrigerant. Okay? So when charging blended refrigerants, you have to charge with liquid refrigerant. Now going back to fractionation and temperature glide, if you put your freon gauges and you connect them to a system, and someone charged that system with a blended refrigerant, you might see the pressure go up at one point, and then all of a sudden the pressure drops. And then the pressure goes back up again, and the pressure drops. That's called a temperature glide, because temperature and pressure go together. When the temperature goes up, the pressure goes up. When the pressure goes up, the temperature goes up. So if you're getting a range of pressures going up and down at one point in the system, you might have, for example, more oil than water, or more water than oil. So it would make the blended refrigerant go up and down in your gauges, and that's an indication, hey, either someone charged it and didn't charge it as a liquid, so we have an improper blend, or the system had a leak, or the system's contaminated, and we need to get that refrigerant out and recharge it back up with the proper refrigerant. So fractionation is basically talking about blended refrigerants and leaking. So when you're taking a test question, remember fractionation, like a fraction of the freon, is when part of the freon leaks out. Temperature glide is, if you look, you could look at it as a range of temperatures and pressures at a given point. They don't have that here, but you guys do have the old service manual that I sent you the new one today, but on your jump drives you had the old one, and it breaks down fractionation and temperature glide individually if you want to read that. So let's go back to our presentation here. Drop-in refrigerants, we went over that. There is no such thing as a drop-in refrigerant. If the refrigerant leaks, especially a blend, you must recover it, and then you could recharge with the same gas or a blended refrigerant similar to that gas when servicing the unit. But you cannot add Freon to something that's already charged as what they call a drop-in replacement. There's no such thing. Hygroscopic. Hygroscopic means basically it absorbs moisture. R134A, the refrigerant itself doesn't absorb moisture, but the oils, which are ester-based oils, and I'll draw a little line here, ester-based oils, these oils are found in 134A. Oops. 134A. And those oils have a high affinity to water, or they absorb water very well. And so when you're working on a system and you take the lines off a compressor, like a brand new compressor comes with rubber grommets in it, when you take and get that compressor ready to install, don't remove those rubber grommets until you're ready to stick it in the refrigerator and connect the lines up. Don't leave it open. If you're working on a system, don't leave it open and say, well, I'll be back in 3 days with the part. If you leave that up, you can get a lot of moisture inside the compressor with that oil, and water and oil don't mix well together, and you can contaminate and damage the compressor. So I just put this picture here with silica gel. This is what they put in electronics, and when you buy electronics, they put a little pack like that. That's to keep moisture off of the electronic equipment, to keep it from going bad, because these things, they absorb moisture. Also, the same thing like that grandma used to put in the coat closet, like that mildew box that would catch moisture, or in the basement. Those are all moisture absorbers. So let's take a look at the EPA questions. Here, how would you describe a ternary blend? Just think of the word ternary.
4-part blend?
No, ternary is like tricycle, a 3-part mixture.
3-part blend.
Yeah, ternary is, think of ternary like tricycle, it's a 3-part blend. Okay? What is vapor charging method for blended refrigerants? What is the proper charging method for blended refrigerants?
As a vapor.
What's the proper method?
As a vapor.
No, look at it right here. Liquid charging is the correct charge. So when you're charging with refrigerants that are blended, you want to charge with liquid. And you weigh into the high side of the system with the liquid. Okay? Now, hermetic compressor must never be operated when what? There's a dehydration vacuum in the system. You don't want to run a compressor when it's under a deep vacuum. The compressor is inside of a steel ball, and we've talked about compressors, and it has an electric motor inside of that. Most dryers and washer motors, they're open. You can see the windings. Well, the reason why they're open is so that if they get hot, air can cool it down. Well, a compressor, the windings in the compressor are inside of a steel ball. They don't have any place for that heat to go, so it relies on a flow of refrigerant to flow over the compressor to help cool it down. If you've got the system in a vacuum, like you hook a vacuum pump up and suck all the air out, you don't want to run the compressor because you have no refrigerant in there, and you need that to keep the compressor from overheating. So that's why a hermetic compressor never be operated when there's a dehydration vacuum in the system. Now, which of the following is included in a list of good service practices for conserving refrigerant? Do you think
All
that
of the
you should?
above.
Okay, that's right. But you think you should recover, recycle? Yes. Keep system tight. Let's make sure there's no
Yes.
leaks. Find and repair leaks. All the
All of
above.
the above.
Yes, sir. Okay, removing refrigerant. Let's talk about the 3 R's. The 3 R's: recover, recycle, reclaim. Recover is you have a refrigerator and you have Gerald, mute your microphone, please. You have your refrigerator, you have your recovery machine, and you have a tank. Recover is to take the Freon and use a recovery machine and pump it in a tank. That's recovery. It's taking it out of the appliance and storing it in a tank. That's it. Recycling, and I used to have a machine that's a recycling machine. It would pass this Freon. After it's in the tank, we could hook it up to the recycling machine and it would circulate that Freon through a set of filters, trying to get moisture and contamination out of there and sort of make the refrigerant almost like a brand new refrigerant. So we would recycle the refrigerant after it's been recovered. Most people don't recycle, but it is something that can be done, but the recycling equipment is quite expensive. I think back in the day I had one in the 90s that cost almost $4,000. Excuse me. So recycling is to filter out moisture and particles inside of the system. Now reclaiming, you as a technician or a service company can't normally reclaim their own refrigerant. They need to take it to an EPA approved company, and by doing so, that company would take that refrigerant and they would recycle it, but they would guarantee it as reclaimed refrigerant and then sell it like brand new refrigerant. So they reclaim it and they would sell it as brand new refrigerant. So let's look at the test question. Remove refrigerant in any condition from a system and store in a container without testing or processing in any way is what?
Recovering.
Recovering, correct. So taking it out, not processing it, or not doing anything is recovering. Which of the following leak detection methods is considered the most effective for locating the general area of small leaks? A halide torch, a bubble test, electronic, or audible sound. All of them are leak detectors. An electronic or electronic ultrasonic will get you the general area, like the condenser over here has got a leak, but it might not pinpoint it to what part is on the pipe. A bubble test is for pinpointing it. But the question they're asking you is the general area of a small leak. So the answer would be an electronic or ultrasonic leak detector. They're good, but they only get you in the general area. They're not going to tell you, especially if you're in the refrigerator or in the back of the fridge. You want to disconnect the condenser fan when you're doing this, because the condenser fan's running, so if you're leaking Freon, that it might blow the Freon away so your leak detector cannot detect it. Okay? Now, recovering during low ambient temperatures will do what? Basically, if you're recovering and it's cold outside.
It was slow
Very good.
recovery
It'll
process.
slow the recovery process, because the colder it is, the lower the pressure. So therefore, it's going to take a lot longer to get it out. If we're working on a refrigerator and we're trying to recover Freon and the compressor of that refrigerator is not working, we can't use that compressor to help get that Freon out. We could use like a heat lamp and put that in the refrigerator and put it up against the evaporator to make it warm so that it will help push the Freon out. But if it's cold outside and it's cold where we're doing the recovery process, it'll take a lot longer to recover Freon if it's cold outside with low ambient temperature. Okay, the reason for dehydrating the refrigeration system is, what does it mean when you're dehydrated? You need what?
Moisture.
right?
Yes, remove water and water vapor.
Yep.
Okay? Number 23, why should care be used not to overfill refrigerant in storage cylinders?
The internal pressure of the cylinder may rise in heated areas
Yes,
and cause an explosion. I'm sorry, I'm on my phone, so it's hard to read.
it's okay. If you try to overfill refrigerant storage cylinder, when it gets too hot, the pressure rises. That freon needs a little bit of space to expand. If it doesn't have a space to expand, the tank is going to rupture, and that's dangerous. What about number 24? What's the maximum percentage you should fill a recovery cylinder?
50%?
No, 80%.
80. Okay.
80% is an acceptable recovery, and we talked a little bit about that. Remember I said that you're going to weigh it, and you're going to weigh it, and you're going to weigh the tank when it's empty, and you're going to, remember we said 24 pounds out of a 30-pound cylinder plus the weight of the tank, and that's how we know we're 80% full. Okay? And the last question, when transporting cylinders containing used refrigerant, DOT requires that you do what?
All of the above.
All the above. Very good, Gerald. You're going to pass this test if you keep practicing it. So when transporting cylinders, we need to make sure it's an OSHA-approved container. DOT is Department of Transportation classification tags. Those cylinders need to be labeled. If that truck gets in an accident and those tanks are strewn out across the street, recovery people, whether it's fire department or tow truck drivers or whatever, need to know that the chemical's safe or not to deal with. And the driver's supposed to have a manifest of how many cylinders of how much refrigerant they have on their truck, so when they're cleaning up the wreck, if the tanks go flying everywhere, they can account and say, oh, he had 100 of these, he had 20 of these, and 30 of those, to make sure that we didn't leave anything out. So they're required to have a manifest or a list of all the tanks and how much refrigerant they're carrying on their truck. All right, guys, so I went over the answers. I need you guys to practice them. I will do another core lecture probably Monday. I'm not going to do one tomorrow. I'll do another core lecture on Monday, and we'll go over some more material that's pertaining to this EPA test. You guys have any questions on this?
Where can I find that that manual?